Okay, so should be live now. Liked about them and what I do not. Why is the topic for me pretty interesting? This is the sentence: I'd rather be writing programs that write programs than write programs. I don't know if you heard it somewhere. Like, no, like this is something I picked up a while ago. Like, I think 50 years ago when I was in Croatia. I don't know where I saw it. I saw it in written somewhere, and it's hard to find it online. This and the variations of it, like I'd rather be coding programs that code programs than coding programs, but I couldn't find it. So I simply say author unknown because the sentence is not mine. I've heard it somewhere, but at the time it actually reflected a lot the way I was approaching programming. So whenever there was a chance to do some I feel strange. It's good. Am I audible? Something? Okay. So to all those out there, I hope you can hear me. Let's wait a few seconds for confirmation. So anyhow, I'll proceed. Uh, back to the sentence. I was really one of those. I don't know, like if you ever had this feeling like you have to write some program, but you immediately see, okay, I have repeating code or whatever, like what we discussed now for the before we started the modeling and so on. So I will actually write a program that writes code for me, you know, like and so on. And the topic was always interesting for me, and also especially this idea of how it's called the metaprogramming. Giving a bit of a Rocky just came out, giving a bit of a context in general where the source generators fits or do not fits, as we will see. Anyhow, a couple of years ago, I stumbled upon this book. It was called Metaprogramming in .NET. Yeah, and when I saw it at first, I said, something's wrong with the title. Like there is no metaprogramming in .NET. You know, why I thought so? Because at the time I was very influenced. I was a C++ programmer before, and I was very influenced with the book which had a similar title, actually a couple of actual collection of articles about metaprogramming in C++. And what was it for me? This metaprogramming. So the idea was you write a program in a language, and the compiler takes that program, and actually the compiler generates the code in the same language out of that code. This is something that C++ templates can do actually. So you have a language construct, a template, and you can write the template in a way when compiler sees them, the compiler will at the compile time actually generate code out of those templates and compile it. And that was something what I considered to be metaprogramming, like this in the full sense of the word. So I have a feature, a language feature, actually deeply integrated language feature, which allows me to write code in the language, which the language compiler will then generate the code out of it. Yeah. The similar thing later on I found in Lisp. I was also really thrilled about it. So it's called macros, where again in the language itself you can write a code, and the compiler will analyze that code, okay, during the compiler time or whatever, and generate the code. And that's something we cannot do in .NET, this kind of metaprogramming. So when I saw the title, it was like something's wrong with the title. Yeah, but still the book broadened my view on the topic in general. This is something after I went through it, I actually agree with it, especially this second part. It's the vast array of code generation options in .NET. So the metaprogramming as presented in this book was in general like the approach to writing programs or writing code that generates code. Yeah. And it starts with the things like T4. I don't know if any one of you used it like in practice. Really, did you have a yeah? And I don't know how was the experience. Not good. Madhu. Yeah, they're definitely very difficult to debug in general. I don't know if you use those there was that additional tooling which gave a kind of a syntax highlighting and let's say better experience to T4. But let's say that it wasn't the first class citizen. Yeah, but that was just one of examples where we use again something different. It was a templating language. Which allows us to build to generate code, C# or whatever, and it was somehow integrated into into in general the development pipeline Visual Studio.
But the interesting part for me in the book was this other part when it discussed of the things like emitting code at runtime and seeing that also as a kind of a metaprogramming, something which a lot of frameworks do, and we are aware of it or we are not aware of it. But the whole point was something generates code for us. I will take maybe an example. If you use maybe again a simplified example, just that you have an idea, and we will take a look later on some others. But I guess most of you've seen, for example, AutoMapper or a similar, where essentially what that framework has to do, it will analyze whatever classes or whatever at runtime, and then generate the appropriate mapping also at runtime. So it was a code generation, different options on a much broader scope. And so when I've seen the proposal, the first original proposal for source generators in C#, I was pretty thrilled. It was like getting again not this C++ kind of experience that we have a full language support, but again something which was quite close. But when the implementation came, like I remember when the implementation came, when they announced it at the build, first I was surprised because it was like, how did they got it that far, that fast? Because it was proposed as a feature which I perceived as something that will take some more time to implement. And then when I saw what is actually implemented, I was a bit disappointed. And here I would like to give you first the idea of what was originally proposed for this feature and what was not implemented, and why I was a bit uh, disappointed. Just that you have a feeling what is it about and what actually can and cannot be done with it. One of the ways of generating code, let's say on the fly, was aspect oriented programming. Like if you ever try to use the how it's called, post sharp, is it? Yeah, post sharp or Cody. I don't know if you have experience with that. Yeah, I hope that one was good at least. I don't know. So what was the idea of that? Like the aspect oriented programming. Uh, Usually, I will take a classical example, or really the classical example. This annoying I notify property changed. Yeah, in WPF or whatever, where actually you always have to write a lot of boilerplate code to add this functionality to a property. Yeah, and essentially with aspect-oriented programming, you simply say, I need this functionality of all the properties. And at the moment, the only way to do it somehow in .NET was actually to modify the code which was generated by the compiler and add this functionality, literally on the IL level. And when I saw the proposal for the first, I will show you now, because it's in GitHub, so it was possible to dig it out. I will show you now the original proposal for the source generator. I think it's this one, that you get that you get an idea and explain a bit around it. So what is the maybe general idea about the source generator? So the compiler will, or no, just a sentence before, which I forgot to say. Those other kinds of code generations like T4, they still definitely have their place, but at least in the cases where I was using T4 in general, usually you had some definition of the source for that what you want to generate was some kind of outside entity. For example, you had something in a whatever JSON file, and then you interpret it and generate the code or whatever. Source generators come in play to in another one use case where you want to generate new code based on the existing code. So somebody wrote the code, the original code, and then you want to generate something based on that code. Yeah. So to come to this I notify property change example, the let's say canonical one. So the programmer will write a class with a couple of properties inside, and then for every of the property which is in that particular file, we want to add some additional functionality. Yeah, and essentially how it works. So I want to write my own code, which gets the original code as input, analyze it, and then essentially creates an additional code which compiler then picks up. And this was the original proposal, just an idea from the original proposal, which I was pretty thrilled about. So what we have here is the following. I have the original class. This is the original class C, and then you can see that this original class has something. Okay. So the proposal was that we were able to write a code which can actually override the things which are defined in this particular class. So the idea was to have two new keywords like replace and original. Okay, where I can literally generate this code. So this is the code that I generate, that my generator generates. Okay, but as you can see, it literally overrides the original code. So I'm replacing the original voidf with my voidf implementation. I can add inside what I want, but I can also call the original. Do you understand the idea? Okay, and this was then what compiler will pick up and generate the code in the background. To come to this example of the I notify property change, I have a property P. Okay, so what I can do is I can replace a P with that code which adds notify, on notify, and end, and just call the original inside, which will call the original implementation of the getter and the setter. Okay, so I saw a strength here. So essentially, in the possibility to literally have, let's say, a support on the compiler level for aspect-oriented programming. It turned out that this was not implemented. What was implemented is conceptually a similar thing. You got the code as input, okay? And you can generate a new code which compiler will pick up. I will show you later on how, but you cannot alter the original code. Okay, so this is I see it as a limitation. C# team sells this as a feature, a kind of that you cannot alter the original code. But this is something where I was a bit disappointed. I think they narrowed the possibilities. Yeah. So since I'm already in code and so on, I will show you now how they work conceptually, and what's the basic idea of the implementation, how to implement um, a source generator, and then later on I will explain why. So when they took this path or this shortcut, as I said, I was personally a bit disappointed. But still I understand what are the benefits and why it was introduced as such, which I will explain afterwards. But now let's dig a bit into the basic idea. I will skip a couple of slides just to come to this. I call it a canonical image. It was in this blog post introducing C# source generators, and they were literally introduced for the first time. It explains this, what I was saying already, essentially how the thing works. Okay, and what do you have to know and what do you have to understand? So the compiler will during the compilation analyze the original code, which is in projects, or which is in a workspace, how it's called on in a compiler um, um, uh, mm, terminology, but or you can just say a solution. And so the compiler will check in the project in which you are at the moment which generators are registered. So you will see the generators that packed in assemblies. You just reference them as third-party assemblies, and compiler simply picks them up, see that they exist, and it actually provides access to the original source code to the generators. For that, it uses, and this is the part where the whole Roslyn API becomes very important. We will see the examples. It used the Roslyn API to provide you access to the original source code. So you know which so-called source trees you have and so on, what is in the source code. So you have all the power actually of Roslyn which you can use. And then your analyzer should analyze that source code, of course. And now comes the interesting part. It literally generates a new source code out of that, whatever it wants. We will take a look on some real life examples. And this new source code is added back. It's actually given to the compiler. Compiler will consider that also when compiling the overall project. Okay. And it will resume with the compilation. Sounds nice. A lot can be done with this. There are again certain limitations. For example, if I have several code generators, I cannot combine them, so they're not composable. They will all get the original input, the original source code as input. They do not see the output of each other. For example, to come again to this canonical example of I notify property change, if I want to have this functionality and then on top of it add, for example, the logging for the parts and so on, such a kind of things are not possible. Yeah. Good. So keep this in mind when we now start just going through some simple examples, and then we will move actually to the parts which are powerful about it. Before I hand over to Bernd, I think what we want to show is actually how they use it on a real life project to really solve a complex topic. I'll start with very simple example. There is this handy website. It's called Source Generator Playground. It's very simple playground, but yeah, it helps to really to at least for this to show the major idea. So this is my original source code, okay? And as you can see, I have just some program and a method, and then I'm calling something, okay, in this source code, but I didn't reference that anywhere. So you can see that I don't have any usings or anything, okay? So that means the question is where this comes from, okay? So I have in my source code something, and then I'm using it, but actually I didn't define it anywhere. And it literally compiles. So when I refresh it, this code actually runs, and you can see the output of the code. It actually writes something. So the question is, where does this hello world generated hello world say hello, where this comes from? So the idea is that the generator generates class called hello world generator. It generates it generates the namespace hello world generator. It generates the class and the static method. Okay. And how that generator looks like, you can see you can see it at the right side. We will play with a bit, but here it's very simple. But it's a perfect example, really hello world example for the generator. So essentially, a source generator is nothing else but a class which implements iSource generator, okay? And it's tagged with the attribute generator. All of them are coming from this Microsoft code analysis namespace, okay? So how this interface looks like, the interface is also very simple. It has only two methods to implement. One is called execute, which is actually the method which is called when the compiler is asking the generator do what you have to do, okay? And the interesting part is this: the compiler will give you over, if you come back to this, the compiler will give you over the original, it's called compilation context. It will give you over the original, let's say, source code in something called generate execution context. And then the second method, which you do not need to implement, is called initialize, which is called only once when the generator is let's say attached to the toolchain, to the IDE or to the compiler for the first time. I will tell a bit more about this later. At the moment, the only important thing is this context. Okay, so what is the idea now? When I start compiling this code, okay, so the compiler will take the original code, okay, and it will pass me that code and everything else what's in my workspace within this context, where you can see it here. So the context has a so-called compilation, which gives you access to the structures which actually Roslyn compiler generates. They're called syntax trees. I will not now go into details how Roslyn works and the Roslyn API. It's important to understand it on the intuitive level, I would say. But how it works, in a simplified way, I will get a syntax tree for this piece of code. And in that syntax tree, I will know that there is a namespace, there is a class inside, that the class has methods and so on. So I can actually inspect these syntax trees. We will see later on a bit more complex example. And so what this code is simply saying, for each syntax tree, it just literally has a piece of a code which is handwritten. It's a plain text, okay? And to the end of this code, it adds this one additional line where it only puts the file path of the file if it exists, which is in this syntax tree. The important thing is this. So at the end, I have some literally piece of a code which is represented as a text, and I'm adding it back to the context. This is the crucial line. Essentially, to go through it once again, it's pretty simple. To get a source generator, I just need to implement iSourceGenerator, the execute method. The execute method will, within the context, it will give me the access to the original code. I have to analyze this code. In this particular example, I'm not doing much. I'm just saying, tell me the syntax trees. I will show another one example. And I have to generate my own code based on that, whatever it does. And I have to add it back to the source, to the overall source, which compiler will then take into consideration. Okay. Now, the playground gives me here down there the code which I generated actually. Okay. You see? And so this is the generated code. Essentially, what the compiler compiles at the end are these two files. Do you understand the idea? This one, the original, and the one which we added. Okay. So once again, the compiler starts the compiling process and builds the information about the original source code. It notices, oh, there is a source generator in the project. It's referenced via it is in one of the reference assemblies. It passes the original source code, simplified, yeah, accepts the additional code, which is this one, and then combines them together to provide the final compilation code, which is going to be compiled. Okay. It doesn't have to be. So this is now the tooling part. Can I see this code really? It can be also seen. I can show this later. Or maybe I think it's better that Ben tells you how the experience really looks like in Visual Studio and so on. But the short answer to this is yes, you can see it also. You can also debug through it and so on. Set breakpoints. When the whole thing came out, the very first version, the tooling support was very bad. I was playing with it a bit. The tooling support was really, let's say, not optimal. And now it's better, but Ben will say a bit more how the development experience looks like. Yeah. But the short answer is yes, you can see the source code. It's well, I did it actually here. So when you do something like this, emit compiler generated files, you set it to true. then you really get those files. Okay, somewhere emitted. This is fine so far. So this is just to explain the overall mechanics. Okay, and now the interesting thing is to see why the feature is there, or there are several reasons why it was introduced. I want to present one which I see as a crucial one, and to that I will go to one to a non-trivial example. Okay, just that you see a bit how the code analysis looks like and so on, and where the feature actually comes as a very, very mighty feature. Okay, so we all use dependency injection. Like, is it like in .NET Core, the built-in one, or you maybe use some dependency injection frameworks, but you understand the overall idea. So you register your types, and at a certain moment, you will say something like get service. Okay, and now this get service call is interesting for dependency injection. There are in general two ways how it can be implemented. Either when the get service is called, like via reflection and so on, the dependency injection framework has to figure out what to build and how, and it will build it on the fly really at that moment using reflection. Okay, which means it's going to be, let's say, slow, and we need to use reflection. And the second possibility is when it's done for the first time, the framework can emit the code. Okay, and now with emitting the code, we are in this runtime metaprogramming area, where for the first time it will emit the code, and next time when somebody says get service IFU, the already emitted code will be executed. Okay, and this is just one of the examples of frameworks which actually do that. During runtime, they use reflection to analyze the types and so on, and then either just during interpreting they do something, or literally they emit the code. Okay, which is something we used for ages, and there are plenty of frameworks like that. The interesting thing is they cause issues if you want to use ahead of time compilation, or if you want to use IL trimming. I don't know if you try to use these features so far. Did you try to use this standalone executables in .NET Core, or these kind of things? Yeah. Okay, you try. Okay. If I do a simple console app, if you just have a feeling, I have a simple console app, hello world, okay, and then I create a self-contained executable. How big will it be, roughly? 100 megabyte. Used to be, now it's a bit more, but we're talking about the tens of megabytes. Okay, just for the hello world. Why? Because the framework is inside the DLLs, the runtime has to be inside, and then I'm going to show you one extremely cool thing now. That you get an idea what IL trimming and what ahead of time compilation can do. And yeah, for the ahead of time compilation, the idea is literally to take the source code and then create the native code at compile time. If you're writing an application which actually doesn't need any of these features which need virtual machine, like code emitting or reflection, we actually want to have an executable, let's say a one similar to the one written in C++. Here is a really awesome example. There is a long blog post where the author explained how it did it. So you have a self-contained C# game in 8 kilobytes. So when I wrote it, I thought it's a marketing trick. Like, no way. Okay. Just to get an idea, here it is. How it looks like. It's just that snake game and so on. The whole point is, for the snake game, I don't need any reflection. I don't need code emitting on runtime. I don't need, like garbage collection is a neat thing to have because it's C# and so on. But essentially, I do not need the features which are needed from virtual machine. And also for this, I don't need the full-blown .NET framework, like .NET or .NET Core framework classic or whatever. Okay, so the author was doing, he was showing different options how big the game is when you do a self-contained executable using different compiling options. The just if you just release it, it's 65 megabytes, okay, which is something roughly what you said, 100, okay. And then he was turning on different options. This one is interesting. Publish trimmed, okay, which means the so-called linker will analyze your code, okay, and try to figure out intelligently which parts of the framework you're actually using, and also which methods of the classes and so on, and it will try to extract and pack only those things which are used, okay. And this is already a huge difference, okay. But the thing goes even more. Now this is extremely cool. Core RT, it's not the run, it's not a runtime, so it's a library actually, which gives you these features which usually the runtime is giving you, like for example garbage collection and then okay. But it's not a virtual machine, okay. And you can see here that we are like pretty much very down low at 4.7 megabytes, okay. Anyhow, I will not here go into details, but at the end, he literally managed to create a single executable for the game, which had only 8 kilobytes, okay? And this is literally a native executable. So, but to be able to come even to this size, which is already wow, you see this point here, reflection free, okay? To be able to really use this feature, you have to be able to explain to the I will say now here, linker or whatever, that you're actually not using the features which need virtual machine, okay. Why to do this? You can imagine it like, like smaller containers, whatever, or even more important now for Blazor, you actually want to really get for the uh, WebAssembly, you want to have ahead of time compilation and really as small as possible, okay. And where is the catch now? If I come back to this example, nowadays, even if you do not use reflection in your own code, okay, or you do not emit anything in your code, most of the time we do not, it's very likely that we use libraries and so on which do such things in the background. Dependency injection being a typical case, okay. And the mighty thing is with source generators in this particular case, they can take over this emitting part or reflection based part and actually do it at compile time. Let's go through this example. This example is pretty cool. So what do I have here? I see in this code that somebody needs IFU, that it's called get service for IFU, okay? And also for iBar, okay? Normally, my dependency injection framework would generate or emit the code at runtime, which finds service for IFU, okay? But now the idea is I want to have a generator that analyzes this code, that figures out what's used, and then generates my service locator exactly for that what's used, okay? This is a simplified example, of course, but you can see here that I have some implementation which gives me the implementation of IFU and iBar, okay? Now look what happens with the generated output when I delete this line. Did you see it? Did you see what happened? Yeah, it just removed the second one. So I will bring it back. Opa. Oops. I think I closed it. Anyhow, but I have it. I have it here. Oh no, not this one. The playground, yes, it's this one. So let's go back to the example. So essentially, yeah, here it is. So the generator generated the service locator class, okay, which can find foo and which can find bar, both of them, okay. But if I remove this line of code, okay, the generator will realize the only thing which is used literally in the project is ifoo, and then it will generate the implementation for ifoo, which looks a bit differently. Do you understand the idea? So this is a much mightier example. What it does, it literally analyzes. Oh, of course, now I know what was the issue. So what it does, it literally analyzes the code, sees what's used and so on, and then emits the code, the locator at compile time. At the end, what it means, I have my dependency injection implementation of a dependency injection framework, which actually does not use or does not need reflection or code emitting at runtime, which means it is AOT friendly, it's IL trimming friendly, and so on. Okay. To the implementation, and yeah. Yes. Yeah. Yes. The output. Mm-hmm. Mm-hmm. Uh-huh. Yeah. Mm-hmm. So in this particular case, what I'm where I'm targeting is making actually my code ahead of time compilation friendly. Let's say, okay, because if I manage to do that, my project will not use reflection. It will not use anything at runtime. Okay, none of it dependencies, and that means once I really want to stream it down, if I need that feature, yeah, uh, it will behave like it will be very ahead of time. For example, compilation friendly or IL trimming friendly. Okay. It was I'm pointing out this. There are a couple of other things which can be done because, for example, what Bernd will show is another one use case. But I'm pointing this as one of the major drivers actually for the feature. This is let's say also where the ISP.NET Core, for example, and other things which we're using will benefit a lot. Okay. Any other questions? Is so far conceptually clear? Maybe we can just take a short look here. Again, I'm just writing a class which implements iSource generator. Here it's a bit more. I will just go to this part. It's of course a bit more complex. Essentially, I'm using Roslyn API here, for example, to find the classes, to find the usages. Uh, for example, to see if the types are used. Maybe I just want to know. I want to come to one. Yeah, this one, for example, just to have an idea. So I'm getting my syntax tree, and this is actually a compiler's view on this piece of code I have. Okay, and then in that syntax tree, you can see here that I'm actually searching for to the top. I simple. Where is it? To the top. Essentially, what I'm searching for, is this invocation expression. I'm trying to see trying to find the piece of codes which call get service. Okay, and this is actually what this query is doing. So within this code, find me the code which is of the type invocation expression syntax. That means the code where a certain method is called, and then I want to check that the method is called get service and then. So I'm using Roslyn here essentially to find pieces of code which I'm interested in. Okay, and later on, out of it again using Roslyn, I'm extracting which interfaces are used, and then generating the appropriate code based on that. Yes, yeah. So in this case, actually, two files are created. So this is the service locator CS, and then another one is this transient attribute also. So it's possible to add several files to the output. Okay. Um, actually, so it's 7 already. I would like to hand over to Bernd. This was a more of a, like, let's say, a theoretical introduction. For me, it was important that that you see actually where it fits in general. So still, source generators make sense if you want to generate source based on the existing source code. To that, I have one nice quote here from a really good article, which I recommend, Thinking Beyond Rows and Source Generators and Aspect-Oriented Programming, from Gael Fretur. He's the author of Post Sharp, and he wrote a long essay actually on the overall topic. I definitely recommend the essay, but I took out this sentence. Why? Because we can expect them to be widely used and abused. Yeah. And it is the case, like with every like new features and so on. I actually almost abused it once. It was rather recent. My brother asked me for a certain um, problem he was trying to solve, and literally we came to that. Oh, you can. So I simply said, oh, you can solve this with Roslyn source generators. Oh, okay, what's that? And then I explained him everything, and also a bit about T4, which he didn't quite use before, and so on. Anyhow, long story short, he spent half of a day learning this, trying it out, and so on, to conclude that this will not work. And then he had a working solution with T4, literally, which he was really like very happy about it. It worked perfectly, and he had that one in less than 30 minutes. So it was my lesson learned. There are particular cases for rows and source generators, but the major point is you do them when you really want to create a new code based on the code which you're writing. Yeah. Just a bit more. There are a lot of examples on this. Where is it? There is a repository called C# source generators, and it lists plenty of examples. Let's say some of use, some might be seen as abuse, but it's a great learning material. If you want to have, I will not prepare also a few examples here, but I think if you understand this conceptually how they work, be enough. But there are really plenty of ideas where you can see where they can also be very useful. One of the things is, for example, this where I see getting rid of reflection and code emitting dependency injection frameworks. The other things are the serializers, for example, which again do the similar thing. There are examples of binary serializers, JSON serializers here, and so on. This one, for example. So I will post the links later on Meetup for these things. And maybe just one more example which goes into this direction. Here is a one framework which I like. I don't know if you are aware of it. REST is. So REST Sharp is, let's say, very popular for having REST clients, getting REST clients. REST is interesting in a concept. So you want to have a REST client, but a nice, strongly typed REST client. So here it is how the framework looks like. You define your nice interface, okay, with your nice methods, and you map it to an endpoint which you want to use. And later on, you just have to say, give me a REST client for this nice interface, and this is the domain, okay? And again, what it does, it emits really a pretty mighty class, which then actually create a working HTTP client, okay, REST client. It's really nice to use. I like it, and it has exactly this. If you think what for does, it emits the type at runtime. Okay, so they were one of the first who added source generators into their implementation. And if you think of how that source generator works, it's exactly like the example which we had here. It searches for the invocation of the for method with the type and so on, and generates the code at the runtime. Okay. Yes. Yeah, if they're there, yes, yeah, definitely. This is also so for library designers. Source generators is a bit controversial because at the end, you know, you want to have a library which can be used on different versions of C#, on other .NET languages, and. So for library designers, usually you will use both. So you will still have the implementation which uses the reflection or emitting, and also provide a source generator. But for the users, if the source generator is there, then definitely, yeah. Okay. Any other questions? Yeah, that's the whole other topic, like consuming in general, how to consume REST REST APIs in .NET. Yeah, is it like I've seen from HTTP client to REST sharp, something like this, or generating the clients. I've we can do it. Yeah, we can do it. We can do it later on. The pizza is there. Good. Do we have any questions from the audience? Nope. Or yes? There is a. Okay, so there's a delay, but I'll give you a couple of seconds more, and then I would like to actually hand over to Bernd. He will show really a very mighty non-trivial example where this is all put in use. Okay, Bernd, stage is yours. Thanks, Daniel.
Okay, 1 minute to switch the devices. So, does it work? I can hear myself. There's an echo. Can I? So this is this muted?
No. This is just your screen. This is screen.
Okay, this one is muted.
And this, okay, should work now. Camera doesn't work good.
Again. But audio seems to work now. Yeah. Okay. Okay, unfortunately, no camera, but at least you can hear me hopefully now. Okay, so I will show now a sample. Yeah, I developed for a customer a few months ago. So we are building there a Blazor application. So our customer, Söderberg and Partner, they are building a whole new CRM system for internal use. And previously they had a monolithic ASP.NET, so the old ASP.NET application. And then they started to re-implement everything. And in the back end, they have already a microservice architecture with ASP.NET Core, but they still had this ASP.NET MVC legacy application. And now this, together with us, we started to re-implement everything with Blazor. So it's a strategic decision to do everything full stack.NET. And we started to implement this base framework for their CRM system. And one requirement was to have also a real-time communication with SignalR. And then we thought how we can do this, because the front end should be modular, so different teams are working on different modules. And with SignalR, you have so-called hubs. And these hubs can be used to send real-time messages from the backend to the client, and from the client also to the backend. But each hub uses a separate WebSocket connection. And this is a problem. I will show you now short sample how SignalR works and what the issue is with this multiple connections. I created a simple application so that everyone sees how SignalR works in general. Igor, can you give me my mouse? Okay, thank you. Okay, so in general, if you want to work with SignalR, you create a hub. I created here two hubs, a chat hub and a counter hub. So this is the typical sample that you will find also on the documentation for SignalR. It's a hub that provides a send message method, and this method can be called from the client side. And we have here two parameters, a user and a message. And what the hub does here, it sends a message, or it calls a method called receive message on the client with the same parameters. So that means we can trigger this method from the client on the server, and then the server will trigger a method with this name on the client side. I will run the application, so then we will see what happens. So on the client, we have now two input boxes with the user and a message. And if I click send, now it's nothing special. We will see here the two parameters A and B. But what happened actually behind the scenes? So I will show the DevTools and refresh the page. And now in the network tab, we see that a new WebSocket connection was open. Let's filter it. We opened the WebSocket connection, and now we can see the messages that get sent between client and server. So these are just keep alive messages, from SignalR. But if I send now this message, we see that this message was sent from the client to the server, and SignalR uses a message format with different message types. The target is send message, so this is actually the name of our method that we have here, so send message. So the method name that should be triggered on the server side, and the arguments. So with A and B, these are actually the values that are entered. And SignalR maps it then to the parameters of this method. So user and message. Yeah, and then the server, so the hub, sends or calls this method, the receive message method, on the client. And this is the second method. So we see here the red ones. The server sends a message to the client, and with the target method receive message, and with the same arguments. So the cool thing, so it looks nothing special, but the cool thing is that this allows us this real-time communication. And especially if we, for example, we duplicate this and are putting this next to each other. And if I'm opening, another user is entering the chat and types a message, so, and sends a message, then everyone who is connected to this hub will receive this message. So it works in both directions, of course. And that's how we could implement a real-time chat application. Yeah, so this is basically how SignalR works. And I also have a second page with a counter. So this is just simple counter that gets increased just to have two different hubs. But usually there will not be only one one feature that uses SignalR. Maybe there are multiple features or modules in an application that and all they are using SignalR. So for example, I have now here a page where I put both features or modules, the counter module and the chat module, on one page. So this is probably something very typical. And now let's take a look here again and refresh. What we see now is that on the same page, we have now two SignalR connections because we have two hubs that this page connects to, and that means we also have two WebSocket connections. Yeah, doesn't look like a big problem, but you have to think what happens if you have 1,000 concurrent users, and maybe there are 3 or 4 modules on one page, and all are using a and all are using SignalR, and then you have per user 3, 4, or 5 concurrent connections. What is the problem? On the backend side, when we implement the web application, we usually create stateless applications because they are very easy to scale. Because if you have multiple instances and the load balancer, it's very easy to redirect the requests to different instances. Because if it's fully stateless, it doesn't care which server replies because it has all the information in the request to process it and return a response. But if you have a WebSocket connection, this connection stays open. So we are bound to one physical device. And one thing is it's harder to for load balancer and so on. But another problem is that if you have 5,000 concurrent connections and they all stay open, that there is a risk that you run out of free ports. So the server has a limited number of ports, and for TCP connections. And if you have a lot of concurrent connections, then you need a lot of servers to handle all these parallel connections. With typically REST calls, it's not a problem because there are not thousands of concurrent requests. So usually they happen, yeah, every few seconds, just a few. But yeah, these connections stay alive and they are blocking the board for as long as the connection is open. And this can be very expensive. For example, in Azure, you have the SignalR service that is actually doing all the scaling for you, because this is a complex topic and it's not so easy to do it. That's why there's a special Azure service called Azure SignalR service. And with it, you can yeah, connect to this service, and in the background, they're forwarding the requests to your instance. But they're actually handling and scaling all the WebSocket connections. And for 1,000 concurrent connections in this Azure SignalR service, you pay 40 euros, I think, per month. And that means if you have a lot of users, or let's say you have only 1,000 users and they have 5 parallel or concurrent open connections, then you already need yeah, 3, 4, 5 instances of Azure SignalR, and that's quite expensive. And that's a problem. And then we thought, okay, what can we do to solve this? And yeah, what solutions do we have to share one connection, even though we have separate modules? And how can we do that to have, yeah, just one single connection for all these different modules that are using SignalR? So that's a short overview. I hope the problem is clear now, and if you have any questions so far. Okay, good. So this was the overview. And now I thought, okay, how can we solve this problem? The first idea, or yeah, first logical idea is, okay, why can't we put everything into one single hub? Of course, we can do this. For example, I created here just one main hub and added all the methods. So the send message for the chat and the increment count method in this one SignalR hub. Okay, but the problem is obvious. I'm putting things together in one class. They do not belong together. They are different modules, and it's not a good solution to have everything in one class that does not belong together. And also, in the end, we want to have multiple modules that are yeah, split up into multiple libraries, and therefore it makes no sense to have it in one class. So what else can we do? Of course, we can make this main hub a partial class and then have separate partial classes for each module. But yeah, it makes it a bit nicer. It looks better and it's a bit more structured. But in the end, it's still one class and you have to put everything into one project. Okay, so then we thought, okay, what else can we do? One idea was to create one service per module. For example, I created here a counter service. So it's just a service class that we can register in our DI container and add here an increment counter method. To answer to this or send a message to SignalR, we need this hub caller clients object. So we used it also here in the counter hub. That's the one that just increases or increments by 1 every time we call this method. And we also use this client's property of SignalR hub and send this message to all others, so not to myself. So if the one who is triggering this method will not get informed, actually we return here the value directly, but all others will get a message with the new value of count. Right, so we can of course do this in this service methods. It's absolutely no problem. So then we can have could have one main hub where we add this method, and instead of doing the SignalR logic directly, we could, of course, then inject we would inject this counter service into our main hub and then call the increment counter method of this service. This would be an option, but there are some limitations and problems, because usually, so what I showed now is that we are using magic strings here to call this method on the client. But in general, we want to avoid magic strings and we want to have strongly types. That's something that SignalR is also providing. So instead of deriving from hub, we could create an interface. I did that already. So for the chat hub, I created an iChat client. And here I describe the methods that can be called on the client side. In this case, the receive message. And now I want to use this chat client interface here, and we will get immediately here an error, because now this send async method from SignalR that uses this magic string is not allowed anymore. Now I must call the name of this method directly. So we have now a method called receive message. That's the one I created in the interface. Oops. So, and now instead of this magic string, I have here now a method call. The same, of course, can be done for the counter hub. Let's do that. Counter client, and instead of send async. Okay. Okay. So now we are using these strongly typed hubs. So what's the problem? In our counter service, we want to call also this receive count on the client side. And therefore, we need to inject the iHub caller clients that we have here in our hub. We have this client's property. So this client's property that we can use to send messages to the clients. And this must be passed to our service so that we can send messages in the service. And this uses the interface to use these strongly typed messages. Right? So we have here also the iCounter client. But if we have only one single hub, then we also need one single interface to describe all the methods that we can call on the client side. And then again, it would be nice if C# would support this, but it's not possible. So if I have the hub with the main client, so the main client is just a combination of the iChat client and iCounter client. And it's not possible to cast this, where do I have this client's property? This client's property is now an iHub caller client with the generic parameter iMainHub. But what we actually need here is the iHub caller clients with iCounter client. And it's not possible to cast this. And it would be nice if it would work, but I had this requirement multiple times. That would be nice if it works, but yeah, it's not. Yeah, the problem is that the compiler, also the generic parameter, or this type with this generic parameter is actually one concrete class, and therefore it's not possible to, because this is an interface here, but as far as I know, that the compiler generates one class for each generic parameter. This one. Yeah. Okay. Yeah. So this doesn't work then as well, because we can't depend all our modules on this shared interface that we need to send strongly typed or call the client methods in a strongly typed way. Okay, so this was another idea that didn't work, and in the end we thought, okay, what we need is something like hub modules. So they work independent, but they should provide the same features as SignalR. So we didn't want to write the wrapper around everything. Because another idea was to have just one single endpoint in one hub, something like this, a generic endpoint with a generic endpoint message, and each message has a property like module to know which module we want to use, which method of this module we want to call, and then the parameters object. So this would be a generic solution, and we could do something like this. So of course, in a dynamic way then, but we would check, okay, if the module is the chat and the method is then send message, and we have two parameters in our object array, then do something like this, send message, and cast the parameters to what we actually need. This would work as well, but it would require a lot of reflection magic to do this, because we need to get all these types. We need to check the parameters if they are correct type. We have to cast or parse the parameters to the correct values. And when I thought about it, I noticed, okay, actually SignalR is already doing exactly this. When we saw the messages, we have already this a similar object where we have this method name and then the parameters as array. And therefore I thought, okay, maybe I can reuse this code that SignalR already has. And I took a look at the code, and then I was very scared because there are, I don't know, hundreds of lines of reflection and all this stuff. And then I thought, okay, I don't want to have this in my solution because it's not really easy to understand and to maintain in the future. And therefore, I thought, okay, this is also not the best idea to have this in such an internal project, because it will be definitely hard to maintain in the future. Also, the SignalR logic is all internal, so we can't reuse it. We would have to copy the code, and then it's also much harder to maintain and keep it up to date. Another problem with this approach is that SignalR offers some features like authentication. That means you can add to an endpoint, you can just add the authorize attribute that you know from ASP.NET Core that you can put on an action or in controller. You can also add the same attribute to a method or the whole hub class. And then, yeah, the user must be authorized and authenticated to access this hub method. That's something you would also have to implement manually, or you have to get this authorized attribute by yourself and validate that the user has access. SignalR offers also something like filters. So that's code that you can run before a hub method. You also add a filter attribute, and before the method gets executed, this filter gets executed. And all this stuff you have to implement by yourself, and you have to test it and make sure that everything works. And this is also a lot of effort to do that. And SignalR has this, you can call this methods of a SignalR hub, but there are also some streams. So here you call a method and you get the return value. But sometimes you have something that emits new results all the time, and you just listen to them. You call something and then you get the updates not all at once, but step by step or one by one. And this has a different return type, and therefore you would have also another endpoint for these streams. And yeah, in the end, it's also a complex solution, and we thought that it's not worth the effort to do this. Yeah, good. And then we thought, okay, what can we do? And I just found one, or there are many discussions on GitHub about this topic. And one general recommendation from David Fowler, so the creator of SignalR, was he said if you just want to structure the hubs in one module, in one project, then you should use a partial class and call to separate the different modules. But that's what you discussed before. It makes no sense because you have everything in one project. But then we thought, okay, if we have multiple projects with our hub modules, and then how can we combine this into one hub? And there we thought, okay, source generators could be a solution for that. I want to show you now the final solution, how it works. First, the whole source code is also available on GitHub. We will post the links later to the meetup page. So yeah, here's a short description how it works. Yeah, we will have this partial class, main hub or whatever you call it, and then we generate the other partial classes for each module, but the modules can live also in separate libraries. So how does the solution look like? Let's open it here. So where do we start? In the end, I have here only one main hub. And as you can see, we have here now attributes, a SignalR module hub attribute with a type of a module hub. So we can now create multiple hub modules and can use this attribute to tell the C# source generator that we will see later to create the partial classes for these modules. Okay, let's take a look at one of these hub modules. So this is now the same code as we saw before, but instead of deriving from hub, we have now a separate base class that's called module hub. The good thing is that SignalR is very flexible and they use a lot of interfaces. That's why it was possible to rebuild the whole thing. So we have now the module hub, and as you can see, the module hub has the same properties as a regular SignalR hub. So we have the clients property with the iHub caller clients, and there are also some other properties like the context. This is the hub caller context from SignalR, so this is not a special implementation, it's the same. And also the groups, if you want to send messages to groups, and even the unconnected and undisconnected methods are also added here as virtual classes and can be overwritten in the module hub itself then. Okay, so go to the so as you can see, the sample looks exactly the same as before. We have the send message, we can use the client's property and trigger this method on the client side. So this was one of the goals. It should, if you know SignalR, you should also be able to work with the hub modules. We didn't want to create something completely new that the developer has to learn, because it's much easier if you know SignalR, you can work with this as well. And if you're looking for a problem, you just search how would I solve this with SignalR, and you can do the same with a module because it's actually the same. Yeah, good. This here we are using the magic strings as well, but it's also possible, for example, in the weather hub, for example, we are using here also the generic version with the iWeather hub client. And when we send a message like okay, here we don't send a message here actually. We're just registering to groups. The messages are sent in the background job every 5 seconds. So that's a different topic. As you can see, we would do the same things also with regular SignalR. We can use the groups property and everything. Okay, and how does it work now? How did we solve it that we can use different interfaces and so on? It's because we have a generator that creates the partial classes that extends the main hub, and it initializes these module hubs. So let's take first a look at the output. Igor mentioned before that there is tooling support for C# source generators. It's still not perfect, but at least we can see here the output of the generator. So in our dependencies section here in the tree, there is a separate endpoint item for analyzers. And here we see our SignalR modules generator. And here we see all the generated classes. So let's take a look at the chat hub, for example. So this is now the partial class that extends the main hub. The main hub is the class that has here the attributes. And for each, we create now a method that can be called directly from the client. In our chat hub, this method is called send message. But to avoid naming conflicts, the generator automatically prefixes this send message method with the name of the hub. Therefore, there's at least a lower risk that we have naming conflicts, especially if you write an internal application. It's very unlikely that you have two modules with the same name, and therefore this should be unlikely. But And now if we call this method from the client, we would call chathub underscore send message instead of just send message. And then in this generated method, we are receiving the chat hub. So this is the module hub from our DI container, and initialize it. We need to initialize it because we need to send this this client property and the groups property and the context property. We need to initialize it with the correct instance. So as we said, we have different interfaces for the strongly typed hubs, and therefore we need to initialize instantiate the correct type to use it then in our module hubs. Yeah, and then we just call this method of the module hub. And that's it, basically. So we use this generator to generate a method with the prefix name and then call the method from our module hub. So this was the sample with the magic strings, but we have also the weather hub that uses the strongly typed interface, but as you can see, it looks more or less the same. Just when we initialize the module, we are passing, or we have a generic type here with the interface that is used by the by this strongly typed weather hub. So that's the only difference, and yeah, it gets then initialized with the correct interface. And there's one more thing that we're generating. When we have this strongly typed interface, in the end, when we call this, in the background, so we defined only the interface as I showed you before, but in the end, if we call this interface, there must be also a class that implements this interface. And SignalR itself does it dynamically at runtime, so they're emitting code. And also this is very complex to generate a class based on the interface. So there's also a lot of magic happening. So I didn't want to duplicate this as well. So I'm using also the generator to generate the implementation for this interface. In this case, we have it here. So the iWeather client implementation. And as you can see here, we have here the iWeather interface, and we also derive from the client proxy. So this is a SignalR thing, and when this method gets called, that's defined in the interface, to receive weather update, then we actually just call send async with the magic string. So, but we're not using the magic string directly. It gets generated, and therefore it's type safe, and the compiler will show a warning if we, or an error if we call a method that does not exist. Okay, so that was how it works. Of course, there is a lot of more things that were to consider, and we was able to look at all the internals of SignalR, how they do it, and so we could understand it and to create these SignalR modules. But as we are now talking about the generator, I will not go into detail about that, but as I said, everything is on GitHub and can take a look. But now let's take a look at the generator and how it works. So this is the generator. We have this initialize method that Igor showed also before. And what I'm using here is a syntax receiver. So actually, Igor is probably more an Roslyn expert, but the syntax receiver is a special class that implements the syntax context receiver interface. So I'm having here this private class. And when we register the receiver here, then during the compilation process, there is one stage where this syntax receiver is called. And the idea is that we parse the existing source code. And in this case, we search for our attribute that we added to the module hub, now to the main hub. So we are searching for actually this attribute here, because for each attribute that was added here, we want to generate a class, or we want to generate code. And with this syntax receiver, we can pass the code. And what we're doing here is, this gets called for each node in the tree, the source tree. And if this node is a class, so that's a condition. And if the class has more than one attribute, so this is now for every class in our source code, this has more than at least one attribute, we step into and analyze it in more detail. So we get the class symbol, and then we check, or we get all the attributes. And if the attribute is of the type, or if I'm using here a string matching, so if the attribute class is actually this constant here, so I defined it at the top. The attribute full name is the namespace, SignalR modules, dot, and the attribute name, so it's the SignalR module hub attribute. So if this class has this attribute, I'm adding it to a property that I defined here, so the entry hub classes. So in this first step, I'm analyzing the code and find all classes that have at least one of this module hub attributes. And then I store them all in this list. So this is the first step. And the next step, the execute method of the source generator gets called. And first I'm checking if the syntax receiver is there. So it's just check that it's not, that it's there, and if it's from the correct type. And then I can just loop over all the entry hub classes. In my sample, I have only one, but there can, in theory, be more than one. So what I'm doing here now, I'm getting the module hub types and the hub attributes. So I'm going here over all the hubs, and first is to get here all the attributes that are added. And yeah, I can now get the type that is specified here as a parameter. So that's what's needed. And yeah, then I'm calling here, it's a lot of code and not enough time to explain everything. But so right, here is where I'm just thinking what we can show, and so not need too much time now. But for each class here, I'm calling this process module hub class method that's here. And this is now the part where I really generate the actual source code. So as Igor showed before, this is really just, I have a string builder, and now I'm appending the source code using the string builder and create this class for each of these module hubs. And of course, then I'm getting all the hub methods, and for each method, I'm doing the same. Can expand this here as well. Yeah, whoops. No. Okay. Yeah, for each method, I'm now also so here it starts to generate the method body or the method itself. So we start with public, then it's either void or we have a return type for this method, and then we have the module hub type name. So that's now where the prefix is added. So as we saw here in the generated, we have this prefix and then the name of the hub method. And that's actually what's happening here. So we have the prefix underscore and then the name of the method. And then, yeah, I'm just joining all the parameters in this method and yeah, edit a string to the output. And here we see that we get the type from our DI container called the initialize method. Depending if it's a generic type or not, we use the generic version or the non-generic version of the init hub module, and so on and so on. Yeah, that's it mainly. So it's now a complete different sample from what Igor showed before, because of course the source generators were mainly introduced to resolve this reflection and emit problem, to support the trimming and the head of time compilation, but it also provides the possibility to do completely other things like this. This has nothing to do with reflection, or I mean, we could do the same also with reflection, but it was not really the idea to do this that way, to avoid reflection, to have better trimming or ahead of time compilation. The main goal was here to to do it much simpler than it would be with reflection, because concatenating here some strings is much easier than doing reflection and emit codes dynamically during runtime. Unfortunately, the tooling is still very limited. For example, if you're working on this on the source generator itself in Visual Studio, there are a few limitations. First of all, you can use only .NET Standard 2.0 for a source generator. The reason is that Visual Studio is still running with .NET 4 point something, and this supports only .NET Standard 2.0, and the source generator gets loaded by Visual Studio, and therefore it can load only assemblies that target .NET Standard 2.0. If you don't use Visual Studio, I think it should also be possible to target something else, because if you build it just with the CLI, then it would not be a problem. I haven't tried it, but I don't see a reason why it should not work. And the other thing is, because Visual Studio loads this assembly in its app domain, and if you now change something to get the new version of the generator, you have to restart Visual Studio. So every time you change something, build it, close Visual Studio, open Visual Studio, check if it works. So this experience is not the best. I think if you do it with Visual Studio Code or something like that, maybe, or if you work with just the CLI, yeah, it should be better. But to be honest, I was more focused on getting it done than playing around with the tooling. Yeah. Yeah. And you can debug it in some cases, at least. There's also the thing, this is new. It was added to Visual Studio 2019 already. But if you have, so where is it? You can debug. So this is new. Right. If you go to this launch properties of a generator, so you can set the generator as start project to debug it. You can only either debug a project or the generator, as far as I know. And to know which project should be run together with the, which project should use this generator that you want to debug, you can specify a target project here in this dropdown. So you see all projects that reference this generator, and then you can select one. And if you start now the generator, in theory, it would be possible to debug the generator and for this project. In practice, I get this error. This is a known issue, and the problem is that I'm using a web project that references the generator, and for web projects it currently doesn't work for some reason, probably because something is too long. It's an open issue on GitHub, and yeah, but for other project, if it's not a web project, it should work to debug it as well. Right. So sometimes, yeah, this is a problem that you don't see if this is a yeah, or the generator will generate this method, but it doesn't yet exist, and therefore the code editor shows an error, but it should then be there. Yeah. So I use this .g.cs extension because then all the Roslyn analyzers will ignore this file. So I also added this header. So this auto-generated attribute does the same. So I have it duplicates. But in general, if you have this .g.cs extension, all the analyzers will ignore this file because it's generated and therefore does not complain about invalid formatting or whatever. So yeah, for example, also use style cops in some of our projects, and then it would complain about these files. But yeah, in this case, not, because it has this extension. This .g.cs is you could have a normal C# file as well. That's not a problem. I just added it so that the analyzers ignore it, and they know that. this is a convention that is, I don't know, somewhere defined in the compiler or yeah, but I'm not sure who defined this convention and where it's actually defined and what it does, but it's described somewhere in the documentation that you should use the .g.cs and it will be ignored. Maybe we should think the listeners, if there are any, they can't hear the audience here. So maybe we should first ask for questions if there are any from the remote audience, and then we can still discuss the other questions here. Okay. If there are no questions, then I think we can say thank you to our remote listeners and yeah, close the streaming for the day. Okay. Okay. Bye. Thank you.